We usually think of mass extinctions as terrible accidents of cosmic luck. An asteroid wanders into Earth's path, and suddenly the dinosaurs are gone. But in 1984, paleontologists David Raup and Jack Sepkoski looked at 250 million years of marine fossil records to map out the historical rate of species death. As this timeline of Earth's biological history shows, the mass extinctions they mapped weren't random. The fossil record contained sharp peaks of biological collapse happening with clockwork regularity, separated by strict intervals of exactly 26 million years. There is no shifting tectonic plate or earthly climate cycle that runs on a 26 million year timer. The Earth itself cannot keep that kind of rhythm over deep time. If the trigger for these biological resets isn't coming from beneath our feet, the researchers concluded it had to be coming from above. Something out in the dark was keeping time. That same year, astrophysicists proposed a chilling suspect, a hypothetical companion to our sun. They called it Nemesis. The idea was that our solar system is actually a binary system, paired with a dark, undetected twin. This orbital diagram models how the theory worked. To match the fossil record, Nemesis would need to trace a massive, highly elliptical path that takes exactly 26 million years to complete one lap around the Sun. At its closest approach, this orbit drags Nemesis through the Oort Cloud, the thick shell of icy comets at the edge of our solar system. Its immense gravitational tide disrupts their delicate balance, kicking a massive wave of comets out of stable orbit. A fraction of those disturbed icy bodies would be redirected inward, causing a deadly comet shower to rain down on the inner planets and Earth, lasting for over 1 million years. It sounds impossible to hide an entire star, but Nemesis was theorized to be a red dwarf, or even a failed brown dwarf. These are incredibly small, cool objects that emit almost no visible light, making them essentially invisible to standard optical telescopes. The implication is unsettling. If Nemesis caused the mass extinctions of the past, this cosmic killer is still out there at the apex of its orbit, quietly ticking towards the next shower. To prove or disprove the Nemesis hypothesis, astronomers had to solve a basic physical problem. You cannot map a star you cannot see, and looking for a dark object against the black backdrop of deep space is a dead end. The solution came from infrared astronomy. Brown dwarfs might not emit visible light, but they do radiate internal heat left over from their formation. NASA launched the Wide Field Infrared Survey Explorer, or WISE, to scan the sky for these exact heat signatures. The technology worked perfectly. WISE successfully mapped thousands of faint objects, including a pair of brown dwarfs sitting just 6.5 light-years away from Earth. But when researchers scoured the data for any object bound to our sun out to tens of thousands of astronomical units, the results were definitive. They found absolutely zero evidence of a companion star. The math also backed up the empty sky. Physicists realized that an orbit stretching over a light-year away from the sun would be fatally unstable. The gravity of the Milky Way and other passing stars would constantly warp its path, destroying the precise timing seen in the fossil record. The physical search and the orbital mechanics point to the exact same conclusion. The Death Star is a statistical myth, and the mass extinction cycle must have a completely different cause. The search for the sun's twin actually yielded a completely different breakthrough. In 2017, a team of astronomers used radio telescopes to peer deep into the Perseus molecular cloud, a massive cold nursery where new stars are actively forming. They looked at dozens of newly formed systems and discovered a striking pattern. Almost all stars, roughly the mass of our sun, form as wide binary pairs, condensing together inside dense, egg-shaped cores of gas. This leads to a surprising realization. The core premise of the original hypothesis was actually correct. Billions of years ago, at the very beginning of the solar system, our sun almost certainly had a primordial twin. For a brief time, our stellar neighborhood was illuminated by 2 young, glowing stars, bound together in a swirling cocoon of cosmic dust. So why isn't it bombarding us with comets today? Because, according to the models, about 60% of these binary pairs eventually break apart. Over its first 1 million years, the sun's twin simply drifted out of its gravitational hold. That twin is now just a ghost of our violent formation. It is drifting harmlessly among the billions of other stars in the Milky Way, completely absolved of any role in Earth's history of mass extinctions. For most of human history, we looked up at the night sky and saw a quiet, static tapestry. The search for a hidden, destructive star forced us to reconsider our neighborhood, revealing a cosmic environment that is incredibly active and highly volatile. We are finally building the tools to watch it happen in real time. High in the mountains of Chile, researchers operate the NSF-DOE Vera Rubin Observatory. This facility houses the largest digital camera ever constructed. For the next 10 years, it will scan the entire visible southern sky, night after night, automatically comparing images to instantly detect any anomaly. The sheer volume of data this machine processing is staggering. By looking for anything that moves, flickers, or explodes, the system is expected to generate up to 7 million real-time alerts every single night. The fear of a phantom twin star pushed us to start looking deep into the dark. Today, with the sky under constant, relentless surveillance, the cosmos finally has nowhere left to hide.